Hey guys, it's Ms. Johnson, and I'm back to bring you the second half of Unit 2 Notes 3 on solving systems using substitution. Now, we're talking about algebraic solving today with systems of equations. And the first 6 examples that we did were all just straight equations that were already written for us. Now we're going to take a look at some word problems where we have to write the system ourselves. So I'm starting with number 7 on the back side of your notes page. It says Campus Rentals rents 2-bedroom and 3-bedroom apartments for $700 and $900 per month, respectively, meaning the 2 bedrooms are $700, the 3 bedrooms are $900. Last month they had 6 vacant apartments and reported $4,600 in lost rent. How many 2-bedroom and 3-bedroom apartments were vacant? So how many of each type of apartment were open is what we're looking for. So the first thing is I need to define my variables. That's going to be my first step. I'm going to say that X is my number of 2-bedroom apartments and that Y is my number of 3-bedroom. So then I need to write my 2 equations. So I know that that's what I'm looking for. I'm looking for how many 2-bedroom and 3-bedroom. That's an X and a Y. My 2 equations, I have one that represents the number of apartments open. So there were 6 open apartments. Some of them were 2-bedroom, some of them were 3-bedroom. So I have X plus Y is equal to 6. Okay. Then I also have the money. I have $700 for each 2-bedroom and $900 for each 3-bedroom. And together they lost $4,600 in rent. So that's 700X plus 900Y is equal to $4,600. So that is the system that I'm working with. That's what I need to solve. Now, I don't see any variables that are by themselves yet, but this top equation could be really easily put to get, or to really easy to get one variable by itself. All I'm going to do is solve for x here and subtract y to the other side, giving me x equals 6 minus y, or negative y plus 6. If you wrote it that way, that's fine too. So now I take this phrase and I drop it in for x right there. So that's going to look like 700 times 6 minus y in parentheses plus 900y is equal to 4,600. And then let's solve for y. So I distribute the 700. That's 4,200 minus 700y plus 900y is equal to 4,600. So I can put my y terms together. That's 4,200 plus 200y is equal to 4,600. Subtract 4,200, and I end up with 200y is equal to $400, or 400 divided by 200, and y is equal to 2. All right, so I've got my y variable. Now I need to go back and get my x variable. So I can plug it into the top equation, and I'd have x plus 2 is equal to 6. Subtract the 2, and I get x equals 4. So now that tells me that I have 4 2-bedroom apartments vacant, and 2 3-bedroom apartments vacant. So I had to write the system and then go through and solve it. Now we could have solved this system using graphing like we had been doing the last couple days, but notice that you've got some coefficients of like 700 and 900. Those are pretty big numbers to graph, so that's why it's helpful to solve things algebraically when we can. Let's take a look at number 8. It says the larger of two numbers is 8 more than 4 times the smaller. If the larger is increased by 4 times the smaller, the result is 40. Find the numbers. So we have 2 numbers that we're looking for here. One is going to be the smaller one, and one is going to be the larger. So let's look at our 2 equations. The first sentence is going to be the first equation. It says the larger of 2 numbers is, that's y equals 8 more than 4 times the smaller. 8 more looks like 8 plus. 4 times the smaller looks like 4x. All right, there's one equation. Then let's look at the next one. It says if the larger is increased by 4 times the smaller, so larger increased by 4 times the smaller. The result is 40. All right, there's my system. Now I solve for it. I have y by itself here. That's super helpful. I'm going to take that phrase and I'm going to drop it in for y right there. So I have 8 plus 4x plus 4x equals 40. That's 8 plus 8x equals 40. And then keep going, subtract the 8. 8x equals 32. Divide by 8. X equals 4. All right, I got one of the numbers. I got the smaller number. Now I need to get the larger number. So then I'm going to take that and I'm going to plug it back in to, I'll just use the top equation. Y is equal to 8 plus 4 times 4. That's y is equal to 8 plus 16. That's y is equal to 24. So my numbers are 4 and 24. All right, let's take a look at number 9. It says the state fair is a popular field trip destination. This year, the senior class of Apple High School and the senior class of Eastville High School both planned trips there. The senior class of Apple Valley rented 8 vans and 8 buses with 240 students. Eastview rented 4 vans and 1 bus with 54 students. Each van had the same number of students as did the buses. Find the number of students in each van and bus. So again, the first thing I want to figure out is what are they asking me? Find the number of students in each van and each bus. So I'm going to say that X is my vans, Y is my bus. The number of students in each van, number of students in each bus. Okay, so I have 2 schools that went. I need to write an equation for Apple Valley and I need to write an equation for Eastview. So my equation for Apple Valley is going to look like this. They filled 8 vans and 8 buses to give me 240 students. My equation for Eastview looks like this. They filled 4 vans and 1 bus to give me 54 students, to take 54 students to the fair. There's my system. Now I need to solve it. I don't have a variable alone right now, but I can easily get a variable alone in the bottom equation just by subtracting that 4x. So that leaves me with y is equal to negative 4x plus 54. Okay, that I'm going to use to solve. I'll take that phrase that's equal to y and I'll put it in place of y in the other equation. So that's going to give me 8x plus 8 times negative 4x plus 54 is equal to 240. Distribute that 8. I end up with 8x minus 32x minus, no, yes, no, minus, or plus, because this is a positive, sorry. Positive 8 times positive 54 is positive 432 is equal to 240. Putting my x terms together, that's negative 24x plus 432 is equal to 240. Subtract the 432. And I have negative 24x is equal to negative 192. Almost there, divide by the negative 24. And I get x equals 8. Okay, so that means each van holds 8 kids. All right, so now let's try the other one. For the other equation, I'm just going to use the bottom one again because that y is alone and that's really helpful. I have 4 times the 8 that I found over here for x plus y equals 54. That's 32 plus y equals 54. Subtract the 32 and I get y is equal to 22. So when I write this out as a solution or write out the answer, I have each van holding 8 students and each bus holding 22 students. Students. All right, last question of the notes for today. Number 10, Brenda School is selling tickets to Spring Musical on the first day of ticket sales. The school sold 3 senior citizen and 9 child tickets for a total of 75 bucks. The school took in $67 on the second day by selling 8 senior citizen and 5 child tickets. What is the price of 1 senior citizen and 1 child ticket? So that's what you're trying to find. What is the price? One senior citizen, one child. Here we go. X, I'm going to call senior ticket. Y, I'm going to call child ticket. So I have X plus Y. No, sorry, that's wrong. I have the 2 different days. I thought I had a total number of tickets, but I don't. I have the 2 different days. That's what I need to write. So I have 3 senior citizen tickets, that's 3X, and 9 child tickets, that's 9Y, for a total of $75. That's day 1. Then day 2 was 8 senior citizen tickets, so 8X, and 5 child tickets, 5Y, for $67. That's the system that I have to solve. Okay, now this is kind of an ugly system because I don't have any variable alone and I don't even have any variable that has a leading coefficient of 1. So I am going to choose the top equation and I'm going to solve for the x so that I have x alone. And the reason I picked that is because I recognize that 75 is divisible by 3, so I'll end up with hopefully some nice numbers there rather than some fractions and decimals to deal with. I'm just going to give it a try and see what happens. So if I solve this one for x, I'm going to subtract the 9y over. That gives me 3x is equal to negative 9y plus 75, and then divide by the 3. And just like I thought, I'm going to end up with some whole numbers, which is good. Negative 9 divided by 3 is negative 3y. 75 divided by 3 gives me 25. Now I can take this phrase that is equal to x and plug it in for x right there. So that gives me 8 times the negative 3y plus 25 plus 5y is equal to 67. Distribute those, that's negative 24y plus 200 plus the 5y is equal to 67. Putting those together gives me negative 19y plus 200 is equal to 67. And then subtract the 200. So I have negative 19y is equal to negative 133. And then divide by the negative 19. And a negative divided by a negative gives me the positive, which is what I want because we're talking about a dollar amount here. So y is equal to 7. Then when I plug that back in, I'm just going to plug it into the equation that I found up here right there, since I have x alone, which is nice. X is going to be equal to negative 3 times 7 plus 25. That's x equaling negative 21 plus 25. That's x equals a positive 4. So my solutions tells me that the senior citizen tickets are $4 and the child tickets are $7. All right, that concludes our notes video for Unit 2, Notes 3 on solving systems by substitution. Don't forget to check off your note sheet with Ms. Johnson, and I will see you all later. Thanks for tuning in.